The question says which of the following molecules will show dipole moment. Okay, and actually it is asking which molecule is polar by nature. Okay, always keep in mind, if dipole moment for a molecule is 0, molecule will be non-polar by nature, and if dipole moment for the molecule is non-zero, dipole moment will be polar by nature. Okay, and dipole moment we can find out by finding the geometry also. Always keep in mind, if the molecule is having regular geometry determined by using hybridization, if the molecule is having regular geometry determined by hybridization, it will have zero dipole moment and it will be non-polar by nature. But if the central element is having lone pair, always keep in mind, if the central element is having lone pair, in that case dipole moment will not be zero. Some polarity definitely will be there. Okay, let's do it. First molecule is what? Methane is there. Methane. We have CH4. CH4. In this case, if you determine how many sigma bond are there, 4 sigma bond. Central element is carbon. Okay, and one carbon is forming how many bond? 4 sigma bond with hydrogen. Total 4 hydrogen are there, 4 sigma bond. A 4 sigma bond, then we have sp3 hybridization, and in this case regular geometry tetrahedral will be there by using hybridization. If regular geometry is there and the central element does not carry any lone pair, dipole moment will be definitely 0. Means we can say it is non-polar by nature. Next we have carbon tetrachloride. It is CCl4 is there. CCl4. You can see all the substituent groups are same. Okay, all the substituent groups. In this case dipole moment is 0, but if the substituent groups are different, such as let's say if it is CH2, it is Cl2, in this case dipole moment will not be equal to 0. You should be careful. If all the substituent groups are same, then regular geometry and dipole moment is 0. In this case also all the substituents, all the Cl are there. You can see carbon is forming how many bond? 4 sigma bond. Same situation, it is also is hybridization what? sp3 and tetrahedral geometry, and dipole moment will be 0. Very interesting. Next we have chloroform. Chloroform is there. This is what? CHCl3. You should be careful with the formula. If you know the formula, then you can apply the concept. CHCl3. You can see all the substituent groups are not same, then you should be careful. Okay, why? Because let's say if I talk about CHCl3, in general, let's say 4 sigma bond, it is also forming 4 sigma bond. Okay, sp3 hybridization and regular geometry is there. But if we arrange these substituent groups, carbon is there, let's say this is Cl is there, we have Cl is there, this is hydrogen is there, this is Cl is there. Arrow mark, here we have dipole moment, this is dipole moment is there. Okay, you can see this dipole, this arrow mark going in one particular direction, adding up. That is different thing. In this case you can see electronegativity is different. Electronegativity difference is different in comparison to carbon and Cl. Electronegativity difference between carbon and hydrogen is different from carbon and Cl. This bond length will also be different. This dipole moment length will be different, but somewhat they are adding up. They are going in one direction. So dipole moment is increasing. Okay, these dipoles are there. They are also not cancelling out each other because they are going like this. If they are going like this, then we can say 100% cancellation is there. But in case of tetrahedral, bond angle will be same, bond length will also be same. Somewhere we can assume, but from here definitely they are adding up. Okay, they are adding up, means dipole moment will be there, means it is polar by nature. Okay, in this case we can say dipole moment is not equal to 0 because substituent groups are different. If I talk about carbon dioxide is CO2, and if you draw the structure, carbon always form how many bond? 4 bond. Each oxygen forms 2 bond. How many sigma bond? 2 sigma bond are there. Carbon does not carry any lone pairs. 2 sigma bond. Hybridization will be sp, and then we are getting the regular geometry. What is that? Linear. Then in this case also dipole moment will be 0. You can see we have 0 dipole moment. Methane 0 dipole moment. Carbon tetrachloride, carbon dioxide 0 dipole moment. In this case dipole moment is not 0, then we can say it shows dipole moment. It is polar by nature. We can say chloroform is polar by nature. You might have learned one chemical reaction, Riemann diamond chemical reaction. Chloroform we use, and chloroform is acting. It is showing acidic character. This hydrogen is removed due to minus I effect, and since this hydrogen is removed as H plus, it is considered it shows acidic character. If you like this video, please share and subscribe to the channel.